Hey guys, so I wanted to make a video or even a series of videos about some topics that our students seem to be struggling with in math. And I know if you have ever taken a GED Ready or if you've taken a GED test, there's always a report that tells you what you need to work on, like what kind of questions you missed. And a lot of the times there's patterns. People miss the same types, like several people will miss the same types of questions. And one of these subjects was absolute value. That has shown up a lot on things that our students are having trouble with. So I thought I'd make a video about absolute value, like what it is and how to solve these kind of questions whenever you see them. So absolute value, the definition of it is it's a number's distance from zero. So it's just how far away from zero a number is. So like if I have this number line, let's say that I've got the number 4 right here. So the absolute value of the number 4 is it's 1, 2, 3, 4 spaces away from 0. So its absolute value is 4. But if I look over here and I've got this dot over here, well, how many spaces away is it from 0? It is 1, 2, 3, 4, 5, 6, 7. So the absolute value of -7 is 7. It's 7 spaces away from 0. The absolute value of 4 is 4 because it's 4 spaces away from 0. And the way that they write absolute value is something like this. So what they'll do, they'll take a number, and it can be a negative number, it can be positive, it can be a decimal, it can be a fraction, and they will put it between these two sticks, basically. And so whenever you see a number in between these two sticks, they're asking you to get the absolute value of that number that's in between them. So for instance, on this one, we have a 4 between the absolute value symbol. So how many spaces away from 0 is 4? Well, it's 4 spaces, so the absolute value is 4. Now this one, we have a -12. So how many spaces away from 0 is a -12? It's 12 spaces away, so we end up getting a +12. Same thing with this, a -0.6. So it is 0.6 spaces away from 0. If we have a fraction, 4/6, well, that is 4/6 spaces away from 0. So, again, the technical definition, it's how many spaces away from 0 it is, but another way to think of it is you are just getting the positive version of that number. So if it's already positive, it's just the exact same thing, but if it's a negative number, you're going to turn that negative number into a positive. And so, like, one thing that shows up sometimes with absolute value might be this idea of temperature. So, like, I mean, we know that temperatures can fall below 0. So let's say that we've got the temperatures, it's 7 degrees below 0, we've got 10 degrees, 4 below 0, and 2 degrees. But let's say that they wanted the absolute values of these temperatures. So again, these little sticks that the numbers are between, that symbolizes absolute value. So the absolute value of -7 is 7. The absolute value of 10 is 10. -4 would be 4, and 2 would be 2. And so they might ask you to graph these absolute values on a number line. So all you do is just put dots where the numbers would be on the number line. So that might be something that could come up. Sometimes they even deal with inequalities and absolute value. So like an inequality is just showing you that, hey, a number is bigger or smaller than something. So for instance, for this one here, it's saying 5 is less than 10. So yeah, I mean, that's true. The number 5 is less than 10. For this one, we get 10 is greater than -5. So yeah, 10 is greater than -5. But if we look at this one on the bottom, the absolute value of 6 is less than the absolute value of 13, which is less than the absolute value of -15. So if we're looking at this, if we're ignoring the absolute value symbols, we're like, -15 is not bigger than 13. That's wrong. But whenever we get absolute value, one thing you can do is rewrite the numbers all as positives. So I have a 6, and I have a 13, and I have a 15. So is 6 less than 13? Yep. Is 13 less than 15? Yeah. So that is true because I was talking about the absolute values of those numbers the whole time, the positive version of those numbers, basically. And so a lot of the times, absolute value shows up in real world situations. So that's what a lot of these word problems are, or how we would use it in the real world, or how we might use it in the real world, basically. So they love questions like this in math. I remember seeing a lot of these in school. I see this in like some of like just the GED material we have whenever we work on word problems. So they might say something like point A is 25 miles above sea level. Point B is 73 miles below sea level. Sorry, I forgot the word miles there. And so they want to know how far apart is point A and point B. Now, I am a visual person. I like to draw pictures of this, but you also need to know the math way to do this as well. So point A is 25 miles above sea level, so it's 25. So I put 25 in my little absolute value symbols. And we're going to add the absolute value of negative 73. So since it's 73 miles below sea level, that's a negative 73. And then we're just going to add them together. So the absolute value of 25 is 25, plus the absolute value of negative 73 is positive 73. And then we just add these together. So 25 plus 73 gives us 98. So they are 98 miles apart from each other. And again, if you wanted to draw a version of this, you can most definitely do that if you are a visual person. But this is just how we would do this as an absolute value equation. So here's another example. They love things like this with temperature as well. The temperature at 8 a.m. was negative 4 degrees. The temperature at 1 p.m. was 27 degrees. What was the change in temperature? So we would take the absolute value of 4 and we would add it to 27. So really we're adding positive 4 plus 27, which is 31. So what was the temperature change? It went up 31 degrees. So again, that a lot of times with temperature change, with elevation change, we end up using absolute value for those kind of problems too. Here is another example. So this is dealing with money. The bank account balances of a small business are given for the first 4 months of the year. Order the amounts from least to greatest, and then order the absolute values of the amounts from the least to greatest. So remember, with word problems, we always have to keep in mind what they want us to do. So this word problem has two parts. First, they want us to order the amounts from least to greatest. So we're putting them in order from smallest to biggest. Then they want us to order the absolute values from least to greatest. So first, we're just putting them in order, the numbers they give us. Then we're putting them in order by the absolute value. So let's start with the first part. So just putting them in order. So which of these numbers is the smallest? Now I know that it's going to be one of these two negative numbers, because negative numbers are smaller than positive numbers. But which one is it? It would be this one. So negative $4.99 and 90 cents is the smallest. You're in debt the most. So that means negative $2.12 and 27 cents is going to be next. And then we're just going to put the rest of these in order. So 342 is smaller than 1,600. So that is how we would put them in order from least to greatest without the absolute value. But let's put this in order. Let's put the absolute values in order. So a negative $4.99 is going to be a positive $499.90. $4.99 even. And this one would be $212.27. So now we have to put these in order. So which one's the smallest? This $212.27. Then what's going to come next? This $342.71. Then we'd put our $499. And then our $1,600. So we did both parts of that word problem. We put them in order without the absolute value, and then we got the absolute value and put those in order. Now this one, they want us to put these on the number line. They want us to put the absolute values of these numbers on the number line. So first I have a -2, but since it's the absolute value, that means I'm going to change it to a +2. So +2 is right here. And then I have a 4. 4 is going to be right here. Then I have a 1.5. So that's going to go right in between my 1 and my 2. 3.5 is going to go between my 3 and my 4. And then -2.5. So the absolute value of that is 2.5. So that's going to go between my 2 and my 3. All right, let's look at this one. Which of these correctly shows the absolute value of -4 and the absolute value of 2? So I know that it is not A, because A is showing a negative number. And absolute values are positive numbers, always. I know it's not B, because again it has a negative number. And I know it's not C, because it has negative numbers. So any numbers that are to the left of the 0 are negative. So that means it's gotta be letter D. So here's a 1, this one's a 2, so yeah, that matches this one. 3, 4, and that matches this one, because the absolute value of -4 is just plain 4, or +4. Okay, let's look at this example. An assembly line packages 16-ounce boxes of cereal with a tolerance of plus or minus a ½ ounce. Boxes not within the tolerance are discarded. Which of the following inequalities can be used to determine whether boxes of cereal are discarded? So what this problem is saying is that the weight of the box minus the ideal box has to be within this ½ ounce, basically. So it has to be within this ½ ounce. So what that's saying is that it's got to be at half or greater than half, basically. So if it is so it has to be within this plus or minus 0.5, basically. And it says the weight of the box minus the ideal box must be within 0.5 or it's discarded. You can plug 16.6 and 15.4 to check. So like if we put, let's try this. Let's say we put 16.6 in here. 0.5. So that would give us 0.6. And that is greater or equal to 0.5. So that one works. Now I know that one wasn't very clear, so let's go to the next one. Leslie's checking account balance is $150. She writes checks for a pair of boots costing $120 and an outfit costing $45. How much money must she deposit into her checking account to bring the balance up to $25? So on this one, we really just have to do some adding and we have to do some subtracting. So right now, she's got $150 and she writes checks for a pair of boots costing $120 and an outfit costing $45. And so they want to know how much must she deposit into her bank account to bring the balance up to $25. So first of all, she starts off with $150. She writes a check for $120. So we're going to take that money away. That means that she had $30. And then she writes a check for $45. So I'm going to take $45 away. So that means that she is in the hole $15 right now. They want to know how much money must she deposit into her checking account to bring the balance to $25. So what we're going to do we're going to take this $25 and we're going to add the absolute value of 15. And so 25 plus 15 gives us 40. So how much money must she deposit? She is going to have to deposit $40. Alright, let's try this one. If the average temperature drops 3 degrees each day over the course of 7 days, what is the absolute value in the change in temperature after 7 days? So first of all, they say that the temperature drops 3 degrees. I'm just going to write it as degrees. So if it's dropping 3 degrees, that means that it is a negative 3. And then it says that it is dropping by 3 degrees each day over the course of 7 days. So every single day, it's dropping 3 degrees, and it's doing that for 7 days. So if it goes down 3 degrees every day for 7 days, that means that we are going to have to multiply. So what we would do is we'd take that negative 3 and we would multiply it by 7. So they want to know what is the absolute value of the change in temperature after 7 days. So how much is the temperature changing, basically? So what we would do is we would multiply through negative 3 times 7, which gives us what? Negative 21. But they just want to know the absolute value of it. So what is the absolute value of 21? 21. So the temperature has changed 21 degrees. That's how much it has changed in those 7 days. Now let's look at this one. Julian and Matthew each make a batch of cookies. Julian makes 45 and Matthew makes 48. What is the absolute value of the difference between the number of cookies Julian makes and the number of cookies Matthew makes? So they want to know the difference of Julian and Matthew. So with difference, the order is important. So the difference between Julian and Matthew. Sorry, that is supposed to be an A. Matthew. So what we would do is we would take what Julian made and we would subtract what Matthew made. So 45 minus 48 gives us negative 3. But they want to know the absolute value. So the absolute value of negative 3 is what? 3. So that means that our answer is A. So that's it for this absolute value video. I hope that it provided some clarity, that it helped explain at least some of this stuff to you. So look for a self-check on absolute value to see if you understood the material. And be sure to check out our Google Classroom for more videos, more material that's out there to help you. And remember, reach out to us if you need some extra help. Maybe you need some one-on-one explanations, or if you want to schedule appointments, just reach out to us. You guys have a great day.